Hey everyone, welcome to the Weekly Space Hangout for Friday, October 16th, 2015. My name is Fraser Cain. I'm the publisher of Universe Today, and we have organized an all-star show today. We're going to be talking with our special guest, Dr. Carolyn Porco, about the Cassini mission, what's happening at Enceladus, what's the future of Cassini. It's going to be a pretty exciting show. In addition to that, we've got a bunch of other topics we're going to be talking about. The Jeff Marcy Astronomy scandal, the potential, the super interesting, not saying it's an alien megastructure, but maybe it's an alien megastructure discovery that was announced this week, as well as a really cool conjunction of Jupiter, the Moon, Venus. So it's a really good week for astronomy. So joining us this week, we've got Sandy Springmann. Hey, Sandy.
Hi, Fraser.
We've got Dave Dickinson. Hey, David.
Hey.
We've got Kimberly Cartier. Hey, Kimberly.
Hello.
We've got Morgan Rehnberg.
Hey, Fraser.
We've got Nicole Gugliucci.
Hello.
Gugliucci. We've got Pamela Gay.
Hello.
And as an absolute special guest star, and I am super excited to have her join us, we've got Dr. Carolyn Porco, who is the lead imaging for the Cassini team. Dr. Porco, welcome to the Weekly Space Hangout.
Thank you. Thank you.
So, as everyone knows, this is a live interactive experience. We are glad to take your questions and comments about the stories that we're going to be talking about today. Go ahead and post any questions that you have, and I will pass them along to the team. So the way you do that is wherever you're watching this, you'll see a link at the bottom that says that we're interacting with the audience. Click that, and that'll take you to the Q&A app, and then you can go ahead and post a question there. I only want really good questions today because of our special guest. So I'm going to say hi to Jim Meeker and Nancy Graziano and Marcel Bakker and Leonard Lindstrom, Sylvan Westby, Bert Walters, Thomas Tranneker, Ian Harris, Rick Schwartz, Yolette Averon, Richard Clark. Man, this gets harder and longer. Every week there's more and more names. Andrew Planet, Tom Nathy, Linda Sadek, John Marcello, Bill Kay. I've run out of time. I got to say hi. And a special thanks to Nancy Graziano, who, with the WSH crew, who organized our special guest this week. Once again, if you want to be a member of this amazing community, do a search for the WSH crew on Google+, and join them and help sort of make the show even better. So, we're going to take about 20 minutes, and we're going to have the appetizer of today's show is we're going to talk to Dr. Carolyn Porco. So once again, Dr. Porco, welcome to the Weekly Space Hangout.
Thank you for having me. I'm glad to be here.
So obviously, I know exactly who you are and everything you've done, but could you give people an introduction of sort of who you are and what you do?
Well, I am the leader of the team of scientists who have brought the rest of the world for the last 11 years now, all those fabulous pictures of Saturn and its rings and moons from the Cassini spacecraft in orbit around Saturn.
11 years.
Yeah, we're in our 12th year.
That's just amazing how long we've been getting these images. And so I think when people think about all of those beautiful images that have been coming back from Cassini, the images of Saturn, the images of the rings, the images of all of these moons, of Titan, Enceladus, you had your hands in all of these images that we get a chance to see, right?
Well, all the images from our cameras. There are other imaging instruments on Cassini, but we take the highest resolution ones, and so we've got the best ones, but there are other instruments that take, imaging data.
Right, but so I guess for people who aren't aware, there was a bunch of instruments on Cassini. So which specifically is the instrument that you work with?
I work with the camera system. We call them cameras. So the ones that are called cameras would be ours. They are a long focal length and medium focal length. Telescopes is really what they are, and so they take very high resolution and low resolution, and they were designed together as a system because we found from Voyager that it was very advantageous to have a very high resolution view and then have the wider view to allow geological interpretation. I mean, if you just take a postage stamp of something, it's fabulous because you see incredible detail, but to understand the significance of the processes that you're witnessing at that very high resolution, you really need to have a larger context. And that's why you often see a narrow and a wide-angle camera in imaging systems on spacecraft.
And now, in the 11 years, I mean, how many pictures have come back to us, roughly?
Oh, now these kinds of things are, I learn them and then I forget them.
To the nearest order of magnitude.
I think I'm going to say 250,000 by now. Actually, there are missions at Mars that have blown us out of the water as far as the number of pictures they've taken. But we've got the best.
And so, I mean, for us as the general public, we get a chance to look through these amazing images and see these features and stuff. But I mean, a lot of the work here is being done really for the scientists. So what is kind of the process that that you guys go through to look at these images, to filter them, to send them out to the scientists, and sort of assist in their studies?
Well, let me just answer that by giving you just a kind of, I don't know, summary of all the things that we have done. You think 11 years of images is a long time, but people like myself who've been on Cassini since day one have been at this for 25 years. By the time it's over, it will be 27 years, so this is an entire career, and that doesn't add up the years that we spent before Cassini started trying to get the mission started. So we've been at it a long time, and in my case, just to give you an appreciation of how the job has changed, when we first were called together, we're working with the people at the Jet Propulsion Laboratory who built the cameras. We're helping design them. We're overseeing it all to make sure that the cameras have all the capabilities and characteristics that we need to address all the science objectives that we had on the table. Like what was it that we wanted to find out at the Saturn system? And mind you, with the cameras, we see just about everything. I mean, we see the atmosphere of the moon, of the planet and Titan. We see the surfaces of the airless bodies. We see the rings. We discover new moons and rings and so on. So except for those things you can't see, like the magnetic field, we do everything. So you could imagine the scope of science objectives that we had to deal with. And we had to make sure that the cameras were going to answer the questions that we had. So that was the first 7 years. Also during that time, we're helping to lay requirements on the engineers who are building the spacecraft. And then we have to worry about the mission, the tour. You know, what do we want the tour to do? What moons do we want to fly by? When do we crank up the orbit? How much time do we spend in equatorial orbits? How much time do we spend in inclined orbits, etc.? And then we launch, and we have calibration to do, and we have instrument checkout to do. By the time we got to Jupiter, we're in full dress rehearsal to make sure that we know what we're doing. And we didn't really, to be honest, by the time we got to Jupiter, know what we were doing. And that was a hair-raising time for us to figure out just exactly what processes and procedures. And now I'm talking about myself, but it was true, I'm sure, for everybody else. What did we absolutely have to make sure we knew how to do by the time we got to Saturn? And we had software to write in those last few years and procedures to get in place. And then in my case, because the public really loves the pictures, I really was in a unique position of having to make sure that I had the procedures in place for processing the images. And that was no small feat. And we put a lot of effort into making the pictures as beautiful as possible. I took it upon myself to give the rest of the world the chance to ride along with us through those pictures. And so there's uplink to do, preparing observations, preparing files that get shipped to the Jet Propulsion Laboratory along with everybody else's, that contains the commands for our camera and the motion of the spacecraft. We had to get all that working. And then there's the downlink. The images come back to us. We had to build databases. The images have to get ingested into databases with all the auxiliary information that has to be calculated, so that when my science team, and by the time we got to Saturn, there's, I don't know, 2 dozen of them, 3 dozen of them, they're logging into the database and pulling images. They also have to pull the information along with those images so that A, they could do their science, but B, also they could help us interpret the data on the fly, so that when we have the New York Times or the Washington Post wanting to know what is it you're finding, we had an answer for them. So it's been, the job has changed over these 25 years. It's been a lot of work. And so it's very gratifying to me that it's obvious that the world has appreciated what we've done.
Yeah, I think you really sort of set that idea ahead. I'm getting a bit of an echo from you. If you could mute, that would be great. And then unmute me to talk.
What did you say?
Oh, I'm getting an echo from you.
I'm sorry, I don't know what to do about it.
I will mute you.
Oh, okay.
And then just remember to unmute yourself when you need to answer. So you know, absolutely. I was just going to say that, you know, I've been doing this job for so long. I've been doing this job for 16 years, and so you know, I've been around from when those images first started to come out of Cassini, and I think you, more than almost anyone that I had been following in this field, really understood how enthusiastic the public was going to be about the images that were coming out of these spacecraft, in addition to the science, and really making that available to people and helping give just the public context. And so I think that work to communicate that out to the public has been a really important part of it. So the question that I wanted to ask you, though, is, you know, with these missions, whenever they go to answer questions. You know, that Voyager turned up a bunch of questions that then needed follow-up answers from Cassini. And so I'd love to know some of the questions that you had going there that you feel like you really got some good answers to, but then also, what are some of the new questions that have turned up that maybe we don't have the questions yet, that, you know, Cassini too will have to help us answer?
Well, okay, so some of the questions that we had foremost on the mind, and I'm just giving you the highlights, mind you. One gigantic one was, what was the surface of Titan like? The spectral characteristics of the Voyager cameras were exactly mismatched to the absorbing characteristics of the Titan atmosphere, so that when as you go longwards in wavelength, as the Voyager cameras started to plummet in sensitivity, that's when the atmosphere of Titan starts to become transparent as you go into certain regions in the infrared, as you're looking at the spectrum of Titan. So we didn't get to see with our eyes, that is visually, what was the surface of Titan like. We knew from the other instruments, the occultation experiments and the spectrometers, we had a good idea of what the physical conditions on the surface were, what the pressure was, what the temperature was, and so you could go off and calculate, well, at those conditions we should see, you know, liquid methane and liquid ethane and so on. So we had guesses about what we would see, but we had never seen the surface. So that was a big question, and in fact we made absolutely sure that we outfitted Cassini and its instruments with the capabilities to allow us to do that. Other questions had to do with the rings. I mean, the rings were my specialty until I fell in love with Enceladus, and the best resolution we had on the rings, I'm forgetting now, but I think it was probably a kilometer per pixel, maybe a couple of kilometers per pixel. And we, you know, had, and also the fidelity, the photometric fidelity of the cameras on Voyager were limited compared to what Cassini had. So, you know, we had this visual impression of the kind of processes that were going on and the complexity of the rings, but we still had lots of questions about what caused it all. What we understood in those days pretty well were resonant interactions between rings and moons. We knew that moons could have resonances in the rings would respond in either opening a gap or launching a wave and so on. But there was so much we didn't understand about the details of those processes. Those were questions on the rings. And then on the moons, well, it's really interesting because for the Voyager data, and I was there during the Voyager encounters, I remember those images of Dione and Rhea coming back for the first time, and I'm standing amidst people. I have to say this because it means so much to me. You know, Gene Shoemaker, one of my heroes, Carl Sagan, another one of my heroes. These were the people on the Voyager imaging team. Everybody's trying to make sense of what we were seeing on the moons. And on Dione and Rhea in particular, we had seen this wispy terrain. And I hope you know what I'm talking about. But, you know, from a distance, it looks like someone's just painted white stripes across the surface. And the best anybody could come up with was that these were places where maybe mushy ice, you know, warm ice came up and got extruded out and basically formed the equivalent of a scar. You know, so that was a question. What was really there? And then Enceladus, you know, it was suspected that Enceladus actually might have some kind of jetting or geysering on its surface, and so we wanted to know if that was the case. So, and on it goes, you know, and we've just gone down and we've checked it all off, you know. We know there are no scars. There is no, in fact, cryovolcanism of the type that we had thought we'd seen with Voyager. There's nary a shred of that kind of cryovolcanism on the moons of Saturn. Those wispy terrains, we thought they'd be extruded ice. They weren't anything like that. They were just very fresh, nearly parallel fractures across the surface that when you look at them from a certain distance, a certain angle, look really bright. And the rings of Saturn, we now have a very good understanding of just exactly what kind of processes are going on there. Still, there are some big questions. But, I mean, with regard to the rings, we have way more data than we have ideas to explain them. And what else did I say? Enceladus. Well, what else can I say about Enceladus? I mean, we have been blown out of the water with what we found on Enceladus, and it has pointed the way to, I keep saying this, but it's really true, it's pointed to the way to the place, the best place in the solar system to go ask the question, has extraterrestrial life started on this body? So, you know, I could take very much more than 20 minutes talking about this all, so I'm going to shut up now.
Okay, so, but I would, you know, sort of to the second part of my question, right, with the Cassini 2, you know, as you said, that you went with a big checklist, right? And you were like, what's that stuff on Rhea? What about the shape of the ring? You know, what about the structures in the rings? What about Enceladus? And so on and so forth. And so now, you know, now I'm assuming you've got an even bigger list of questions, like that the whole process has just made more questions in your brain. And so if you could, you know, make Cassini 2 happen, you know, what does that new checklist of questions look like?
Okay, so first, appreciate that you would probably get a different list from any other scientist you ask. We all have our favorite topics, the things that really float our boats, so to speak. And for me, if I were going to, if I had all the resources you could put at this, I would make a spacecraft that would carry an orbiter around Titan, and then also with a lander to land on its surface, because Titan has turned out to be the only place in all the solar system where we have native organics, liquid organics, ponded on the surface. And that makes it so fascinating an object to study. Nowhere else in the solar system could you go and conduct the kind of experiments that we would love to conduct on Titan. I mean, that's it. So I would do that. I'd make sure we had an exceptional instrument package that was down on the surface, and an orbiter, of course, because there's still things we could do with a Titan orbiter. And then at the same time, I'd have this mission back to the Saturn system carry the equivalent for Enceladus. Put an orbiter around Enceladus, do a complete job of mapping its gravity field to understand what the distribution of mass is within it, but then put a landed package at the south polar terrain so we could be there and measure the composition, determine the composition of the material that is venting, as we now know, from its ocean beneath the surface. And I've said this many times, if you want to study Enceladus, all you have to do is land on the surface, look up and stick your tongue out, and you've got what you came for, because 96% of the stuff that's venting is snowing back down, at least the solid material is snowing back down on the surface. So those, I think, are the really big questions that we have now with Cassini. And keep in mind that I probably take a different point of view from many of my scientific colleagues. We could investigate any place we go down to a gnat's eyebrow if we wanted to. We could figure out, one quadrangle on Mimas and decide, we want to understand the mechanisms that have brought about, the way it cracks or the cratering or what have you. But I think at some point we have to say, we go after the big ticket items. We don't have all the resources we would like, and we should really, bite down hard and decide there are, a handful of things we really want to know. And I think that at this point, at least in the study of the Saturn system, the things that we really want to know have to do with what we can learn about the origin of life, both on the Earth and has it occurred anywhere else. And that's why I choose Enceladus, TOPS, and then Titan.
So Enceladus is a great topic, and so there was just a flyby just a couple of days ago of Enceladus, and there's not going to be a lot more, right? You've got 2 more flybys of Enceladus after the one that just happened, and I think the whole thing is starting to be winding down at this point. So can you talk a bit about sort of like what's happened just in the last couple of days and sort of what the future of the Cassini mission is now as we're reaching sort of near to the end of its life?
Okay, so yes, we just had one of our last 3 Enceladus flybys. It was our 20th. And bear in mind, for the nominal mission, the first 4 years, we only had 3. So we have really taken singular advantage of the extended missions that we've had since our nominal mission was over in order to study Enceladus. And I just want to slot in here that this has really been the core of our success, the fact that we are an orbiter mission and we've had the luxury of going back and investigating things that we had discovered initially in the nominal mission. It's been the essence of exploration. And so anyway, we need from now on, we need to put orbiter missions around places like Neptune and Uranus and so on, because those are begging for this kind of exploration. But anyway, we had the first of the last 3 just a couple of days ago, and we flew over the North Pole. Part of the purpose of that was to see at high resolution, did the North Pole look anything like the South Pole, also to allow the instrument that can measure temperature to determine is there any heat coming out of the North Pole. And that's, if I had to put it in a nutshell, the purpose of these last 3 flybys and even the 2 coming up are to understand if there's any excess heat coming from the region, the South Polar terrain outside of the tiger stripe fractures. Right now we know there's gigawatts worth of heat coming out of those 4 fractures, and they are associated with the geysering process. I'm very proud to say this was the result of work that's gone on in my shop. We found a correlation between geysers and the hot spots, and so we know now that the heat coming out of the fractures is the thermal signature of the geysering process. But the question remains, there should be heat. If our ideas about the ultimate source of the heat are correct, and that is that it's the flexing that Enceladus undergoes because of tides raised in it by Saturn, if that's correct, then we should see the whole region emit some level of thermal radiation. And so now that it's winter at the South Pole, there's no sunshine on the surface, there's no passive heating, therefore. We want to see if there's any, there's no sunlight heating the surface. We want to see if the region has any heat of its own. We suspect it should. And then another thing we really want to do is fly through the plume one more time with the instruments that can scoop up material and measure composition. We want to get, press those into action with the express purpose of this time for the ion and neutral mass spectrometer, seeing if we can detect molecular hydrogen. Because molecular hydrogen features looms large in the kind of ecologies that we think are good analogs for what we might have on Enceladus. And notice all the speculation here. We don't really know, but we're doing what we can with Cassini, given that it's, it's there and it has a certain set of instruments. So we're going to use them to do things that we feel are going to be profitable. And we think this might be profitable because hydrogen is consumed by a certain type of organism on the Earth called the methanogen. It can be consumed with carbon dioxide or it can be consumed with sulfate. And these are ecologies that we know exist miles below the Earth. There's no sunlight there. There's not even any material that has been created with sunlight. There's just, the only heat is that which is either, well, I won't get into that. It's just not, it's not sunlight that is heating, causing the, being the source of the energy. So it could possibly be these are the best analogs for what we have on Enceladus. And so we want to know, is molecular hydrogen involved at all? And so far we don't know the status of molecular hydrogen in the plume. And so that's what's going to happen October 28th. Is that next week? No, I guess it's a couple of weeks. So, so that's one of the upcoming things that we're going to be doing. And then also we're going to just look again at high resolution with the cameras and also with the thermal instrument at one of the a certain locale on the Tiger Stripes to repeat an observation we had made earlier to see if there are any changes. So that's what's in store for Enceladus. As you probably all know, eventually in 2 years' time, and maybe earlier, just depends what happens with the spacecraft, Cassini, if it hasn't done so already, we're going to send it into Saturn so that there's no chance it could contaminate any of these other bodies that are of such great astrobiological interest. And at that point, 27 years of a profoundly successful mission will finally be over.
Well, I think at this time, I think, but whatever comes next, right? I mean, the trick is that all of these lessons and all of these photos, this just has whetted everyone's appetite for more science, more pictures, and just we need to know the answers to all of those questions. So I know you've got to run, and I just want to let you know, as a I'm a journalist, but I'm also a huge fan, and the work, the outreach work that you've done in making these photographs available to the public, in helping us all come along for the ride. I'm sure sometimes you got some grief from people, but I want to let you know that we, the public, deeply appreciate being able to see these pictures, to appreciate them, to be able to follow along on the science, and really join in the adventure of Cassini. So thank you so much for your time joining us today. We really appreciate it, and here's to another couple of years of really great science with Cassini. Oh, you're still muted.
Thank you very much. Actually, it means quite a lot to me that people have noticed. I also appreciate the little hat tip to any grief that I've gotten, because over the years I've gotten some. And I just want to ask, if I'm allowed to at this point, how many of you participated in the Day the Earth Smiled? Hands raised? Oh, cool. Okay, very good. Well, it was a great moment. I'm happy that it did get spread around the world. There were people all over the world who participated. So So anyway, yeah. So anyway, here's to 2 great more years, and then we'll all enjoy Cassini in memory.
Thanks a lot.
Awesome.
Okay. Bye-bye.
Bye. Okay. That was awesome. That was so great. All right, well, let's move on. I apologize to all the people who were asking questions. There was a bit of an audio echo feedback going on there, and so I wanted to sort of keep the amount of back and forth down as little as I could. So, but everyone else has got their microphones on, so this should go really well. So let's move on to the next big topic that has sort of broke this week. I'm not sure who I'm going to have to introduce it. You know what? I'm going to let you introduce it, Morgan, and then you and I can get out of the way and let everyone else discuss it. So, what was the big news this week?
Yeah. So
Should we add like a content notice right here that we will be talking about sexual harassment and sexual assault for anyone who?
Damn it! I thought we were about to talk about aliens.
No, we'll get back to
for aliens.
I'm not saying it's aliens.
Yeah, but it's aliens.
It's aliens.
Yeah, so we'll give everyone a content warning that the next segment we're going to be talking about sexual harassment. And so if you have children in the room, you might want to have them go and play with their space Lego for a little while, and then have them join you again when we talk about aliens. Or not aliens. So Morgan, why don't you give us the introduction?
It's usually pretty challenging week to week for us to figure out what stories to talk about, and we kind of tussle over what should make it into our 60-minute sprint and what shouldn't. But this week it was unfortunately very, very easy to decide what we should be talking about, because about this time last week we learned from an article actually published in Buzfeed that a prominent exoplanet astronomer named Jeff Marcy has, over the course of many years, perpetrated a series of sexual assaults and sexual harassments against women in his department at the University of California at Berkeley. And more distressingly, it appears that there were a lot of people in positions of authority at Berkeley who had knowledge of this behavior and yet didn't take any action to initiate some sort of investigation. And even after 4 of what now appears likely to be dozens of women pressed a case under Title IX of the United States Education Act of 1972, the university didn't take any immediate or substantive action to remove Professor Marcy from his post at Berkeley. In effect, the University of California determined that Marcy had indeed been engaging for years in grossly inappropriate behavior, and yet they left him in a position of power within the university that placed additional students at risk. And although he's now resigned his professorship under tremendous pressure from within the astronomical community, the university hasn't taken any sort of public action against those in authority who were complicit in these actions. And before we jump into this discussion, I want to be unequivocal in my statement that this is not just an issue with the University of California, but one that's endemic to the field of astronomy in particular, and to science in general, and society at an even broader level.
Well done.
Well done. Nicely done.
That was extremely well said.
Pamela, I'll throw this to you first. We were really lucky that we had a chance to actually sit and hang out this week. We did this science symposium in Columbus, and big thanks to Paul Sutter, who's not here, but he organized it with us. And so it was great to be able to just hang out with you, and got a chance to talk sort of over beer about sort of your take on this and what was going on. And I think, this is not the first conversation that we've had about this kind of situation happening in your field.
No, but I have to say this is one of those times when, thank God for the mainstream news, something is happening. And one of the greatest sadnesses that comes out of this is the moment of, does the story have to appear in BuzzFeed, the New York Times, the Atlantic, before someone will actually do something? One of the heart-wrenching things is this is something that the women reported years ago. There wasn't silence. And it's only as they've each reached a point in their career where they're secure, that they've been able to go to that next step and not just report it silently to people who should help them, but to actually work to try and help themselves and to help future generations. I learned directly from Berkeley. This was the second grievance process filed against Dr. Marcy, and this was the second time he was given a written warning. And the outrage that I think all of us had, knowing, yet again, it's just words, led to action that was completely unprecedented. This was entirely done in the public and not in some back channel, some closed group on Facebook. This was done in the public. And the thing is, when people are watching, you have to do the right thing. And so, because those women were brave enough to speak on Buzfeed, the right thing happened. And it sucks that that's what it took. But we are seeing organizations like the American Astronomical Society, who had a policy that they then realized had absolutely no way to enforce, are now working to come up with those enforcements. Places like the University of California, Berkeley, that had policies that were designed to deal with student-on-student harassment, are now looking for ways to change those policies so that when faculty act poorly, they have ways for their policies to have teeth. And this is new, and this is tremendous. And I'm hoping that just like several years ago when we watched story after story come out of the military of women being abused, the military cleaned house. They got rid of a lot of, quite literally, the old guard. And now that behavior isn't tolerated, and we see women rising to new levels in the U.S. Armed Forces. I'm hoping that we'll see similar strength from the strong women and the men who are having to make tough decisions as we clean house and make it safe to be in our field.
Sandy, I know you've got to go in a couple of minutes.
I'm actually going to be organizing a discussion for my department on this in 18 minutes. So if you see my office mate and I sort of talking about things or sort of exhibiting excited behavior, it's because of that.
Well, I'd love to know, sort of, as a person who is in an astronomy, planetary science department, dealing with, I'm sure this is sort of being presented in all of these departments, and I would love to know, sort of, how is your group sort of dealing with this and sort of taking this to the next level with your team?
Our department chair sent out, well, a lot of departments have sent out emails reiterating university policies and sort of what the rules are. Sort of one thing that's been sort of difficult on all of this is there's this Title IX provision, which is supposed to mean that there's no discrimination on the basis of sex or other things in academia. But when Title IX is used in these sexual harassment and sexual assault cases, it's more of a sort of a conflict resolution tool. And so usually what happens with a Title IX case is that the people who are involved agree, they come to some understanding with the university, they come up with a way forward, and then you can't talk about it anymore. And this isn't really a legal thing. It doesn't have any, that you don't go through a court of law. There's really no sort of legal basis for it. And so while Jeff Marcy has said that is guilty of assault, this hasn't gone through a court of law. He hasn't been tried by his peers. So you're in this really sort of weird interstitial space between, like, we know he did this, but there hasn't been a civil suit. There hasn't been a criminal suit. So you don't really, there could be a lawsuit after this. Marcy could sue the women who came forward who were quoted in the Title IX investigation, who were quoted in the Buzfeed article. And so there could be sort of more repercussion for the survivors of Jeff Marcy's his assault. And so it's just sort of, the universities sort of have their hands tied, and our professional societies sort of have their hands tied. And so this isn't just a problem in astronomy. It's not just a problem in academia. It's a problem in society. And so another thing that Pamela wants me to bring up is the statute of limitations. If you were to have a Title IX investigation today of a professor, you can only go back 3 years. You can only go back for 3 years of bad behavior. So maybe he's cleaned up his act and he knows he's being watched for the last 3 years and he hasn't assaulted or harassed anyone. But that doesn't negate a career of 30 years of harassing and assaulting women in the field and driving them from exoplanets. And there might have been dozens, if not more, women and other people who were affected by Jeff Marcy's behavior who decided to leave astronomy. And it's also it's also like, you know, what other great discoveries could have been made if it wasn't Marcy? And also, legally, harassment cases need to be filed within some amount of time. I think at the University of Arizona, you have 180 days to report. In Illinois, it's 300 days. In California, it's 3 years. So there's only a certain amount of time over which you can report harassment to the police. And a lot of time, if you do go to report, certainly there was a bully at one of my workplaces, and we tried reporting him, and it really didn't work. And it was finally after almost 2 years of reporting that something happened, but it was because the behavior was so egregious and no one could ignore it anymore. But a lot of these harassers, they sort of have a playbook. They that's been posted on the Women in Astronomy blog, that there's certain behavior that they engage in, and it's part of a pattern. And so it can sometimes take a while for this to happen, and it takes sometimes a while for people to realize that they're being harassed or assaulted. So I think a lot of universities, and I think a lot of astronomers, I've really seen very few deplorable responses about this. A lot of people have really supported the survivors of this, and they have really believed the stories. And because sometimes the astronomy community, we're human after all. We can say some nasty things, and we can be mean, and we can be skeptical because we're scientists, so we need very convincing evidence. But I think though for a lot of people, it's just a reminder that there are other people like Jeff Marcy out there who are protected. They have tenure. They can't be fired, and it's just sort of discouraging that you can expect a career full of interacting with these people, avoiding these people, being terrified of these people, and then it's sort of hard to do work in that sort of environment.
Yeah.
For a lot of us,
oh, I was going to go ahead, Nicole.
I was going to say for a lot of us, it didn't come as for a lot of people, it came as a surprise. I brought it up to my department chair. I'm the only astronomer here, and he was like, "Wow, that's shocking." And I said, no, it's really not. That's the thing, is that it's a very open secret within astronomy. We each have our little lists of who we avoid, who we know to avoid. So it's
not even who to avoid. Sorry, Nicole. It's also to say to your students, don't apply to work at that school. Don't apply to work with that person, and you can't publish these lists because then you get sued for libel.
Right. So we've been discussing how do we know this is just one case. We got to look beyond this. How do we even get beyond that to make it more safer across the board?
Yeah, and I think your point was really good, Sandy, just about the sort of the chilling effect that this potentially has on an entire department, an entire scientific group. And so, Kimberly, this is your field. These are your people. This is your leader.
Yes.
How has this impacted exoplanet astronomy?
So, like Nicole was saying, is that it's been an open secret for quite a while. I myself, but the issue with the open secret is that it has to be passed word of mouth. Mm-hmm. And so the times in their careers when people come to learn of this sort of behavior from these types of individuals is greatly varied. I myself only learned that this was an issue with Dr. Marcy about 1.5 years ago. And I know some more senior people in my department, who postdocs and faculty, who had no idea. So it's really highly variable depending on where you come from and how much interaction you have with other people in the field. And unfortunately, if you work in even the more narrow subfield of radial velocity exoplanets, where Dr. Marcy made his mark for so many years, unfortunately you sort of can't avoid working with his group, working with his data. And so even if you may want to speak out and may want to take overt action about it, you do so at the very great risk of your own personal career.
Yeah.
And that's a personal decision that a lot of people have had to make over the years while this has been an open secret, but a secret nonetheless. So, as someone said before, now that it's open in the public, you do the right thing and you take a step back. And I remember reading Dr. John Johnson's blog post in the immediate aftermath of the Buzfeed article, where he discussed his own personal decision coming to grips with this issue and how do I move forward, knowing that a senior person in my field has been a perpetrator of sexual assault and sexual harassment for so many years, but I don't have the privilege or the security in order to take action. And he said he essentially broke ties with Dr. Marcy as soon as it was safe for him to do so in his career. And unfortunately, many of the people who are victims or are vulnerable to this sort of behavior from predators aren't in a safe position in their career to do that.
Pamela, I think with this specific case, we're still waiting for everything to kind of turn out. We're going to see what the, he's resigned, the allegations have come out, and I think Asandi was saying that, it's going to be a matter of time for whatever legal thing is going to come out. But so in general, though, how do you think that universities can proceed forward in the situation, and how can the allies of the people who are dealing with help out?
The most powerful thing that I've seen so far is I've now had several men who know that I, like every single other woman in our field, has had to deal with my share of these people, and I have a list. And they're saying, who's on your list? How can we help? And that's entirely new, that proactive struggle of we need to be better advocates, and now we know, and now we need to take action. The other thing that I think we also have to pay attention to is, while women have issues of actual sexual assault periodically, there are still a lot of us in the field, 11% at the mid and high career levels, which sounds like zero, but when you compare it to the people of color who are closer to 2 to 3%, we've got it good, and we need to take this opportunity and time to say, we've got a sucky situation, but at least we have a voice. Let's lend our voices to theirs and try and fix both sides of this problem. And so this is a chance to educate the people who have been blessed with privilege that allowed them to have an easier passage through academia. And hopefully, by talking about these problems, by having the senior people who may not have been aware of these problems before say, who's on your list? What has happened to you? Let me listen. And then together, coming up with the policies that will allow action to be taken when things go poorly. I think there's the potential for meaningful change to happen.
Yeah, it does feel like a bit like a turning point. Sonia, I know you've got to run, so one last word before you do.
I want to echo Pamela, and I want to make sure Morgan gets in a last word here. But one of my colleagues, she's black, she's female, she's has a couple other intersections of where she is, of who she is in life, that she experiences discrimination on a bunch of different axes. And she was saying that the sexism she experiences in this field and the harassment is terrible, but what's worse is the racism she experiences.
Yeah.
And so I can only imagine what it's like for her to see just the continuing racist incidents, harassments, discrimination that happens in the field. And so I think one thing that men can really do, and that people who want to help out can do, is they can listen to the women who are talking about harassment, and they can believe them. Because there's really no incentive to falsely report this or exaggerate it, because believe me, it's very terrible to talk about this. I was talking with someone about this on Tuesday, and he was chewing on his glasses the whole time. He was so uncomfortable. So no one really wants to talk about this, but if people do talk about it, listen, and believe them when they talk about racism, believe them when they talk about sexism. And I know you want to put on your scientist hat, and you want to get the details, and you want to make sure it's airtight, but just listen, and then go talk to your HR, see what their policies are, see what reporting. How do you report? Can reporting be done anonymously? Are there statutes of limitations? And just really listen to women, because there are some men in the field who are saying, tell us what to do, tell us what to do. And we're saying, we've been telling you what to do for decades. We're sick of it. So please Please listen.
Pamela was right. What happened in the military in the 80s and 90s is a good model for what needs to happen in academia today. I was in the military back in the 80s and 90s, and it took people to just get serious about, no, we're not going to tolerate this.
Right.
And there was a house cleaning that happened.
Yeah, a lot of the old guard got fired. Well, in the military, you don't get fired, you get retired. But, you know, it's a lot of the old guard had to get shuffled out before the culture changed.
Yeah.
So
so I think... Oh, go ahead, Kimberly.
I was going to say, I think one thing that most people haven't yet realized is that it's not enough just to be on your best behavior. It's not enough to not perpetrate sexual assault and sexual harassment. That's not enough to fix the problem. You need to learn to recognize what is sexual harassment. Understand that it could be different for every single person. There's no one standard list of these behaviors are not acceptable. And learn to recognize when it is happening and learn how to safely take action against it to help out and be an ally.
And the way to do what Pamela and Sandy and Nicole and Kimberly are saying is to make a climate in which it's possible for people to speak out. And right now, if you speak out, especially if you're a woman, and especially if you speak out online, you're going to be met with a very caustic environment. And so for everybody watching this and everybody listening to this, if you want to see scientists, especially women, interact with you in the public, and you want to see these sorts of things improve, you have a responsibility to help make online communities that are safe for people to communicate in. And if you were to go out to any of the brilliant women that come onto our show, and you click on some of the things that they've tweeted, and you read through the things that are tweeted back, it's horrifying. And as other people who I know and see on social media talking about these things, you have the responsibility to step in and say, look, this is not going to be accepted where we are. This is not going to be accepted anywhere. And only then are we going to be able to make it so we have a climate to move forward and fix this problem.
Yeah, I almost guarantee that just this conversation, which is possibly one of the most scientific and conversations on this matter, is going to generate some actual death threats for some of the people who are on this panel right now.
No, they ironically like to threaten rape.
So,
yeah,
okay,
it's rape
I
threats.
apologize. Yeah, this will generate some rape threats, and
they won't be at me.
And they won't be at me. They are going to go directly to the women on this panel. So
I'll be speaking. I'll be on a field trip. So maybe I can FaceTime you.
Whoa, she's
aliens
beaming out. Yeah, aliens have something. So I think
much more data than I do. We can do the space hangout driving through Yuma to the Salton Sea.
Think so.
On that segue.
That's a good segue into aliens.
Yes, it is.
Yeah, let's talk about aliens.
Because we can.
We can. We're not talking about aliens, though. We are only talking about some interesting observations of an extrasolar planet. Isn't that right, Kimberly?
That is exactly right. So this exoplanet is not an exoplanet. It's a star that was observed by Kepler. It has a phone number for a name, and it caught the attention of the citizen scientists over at Planet Hunters, who were looking through the wealth of data that was downloaded from the Kepler Space Telescope and realized that this star was weird. And it was very, very weird. And it wasn't weird in the way that would indicate that it has a planet or a companion star or anything typically normal that we would associate, but it was weird in a way that we'd never seen before. So I'm going to share something real quick, screen share, to see if I can illustrate this a bit better. So here is what a normal planetary transit looks like. It's nice, uniform in shape. It's a pretty U-shaped normal, and it does that on a very regular period and always has the same shape every time. That's normal. Instead, we see something like this once, and then we see something like this once, and then that, and then even weirder. So this star is far from regular. It's doing weird things, and it's doing weird things in a way that does not indicate a planet. And the the people who initially published this star, Tabitha Boyajian and her group, came up with the somewhat plausible explanation of a swarm of cometary-like material transiting in front of the star at random times and random shapes and configurations. Now, it's possible that that could be the explanation. It doesn't, a swarm of exocomets doesn't fully explain every feature that you see in the Kepler light curves. And so, and quite honestly, there's no good, fully natural explanation to explain everything we see. How this ties into aliens is rather out of left field a little bit. This is where I come in. This is something that I was working on in a completely unrelated project related to the SETI initiative, looking for signatures of alien technologies out in the cosmos, and how can we differentiate artificial signals from naturally occurring things like planets. And we developed this way to differentiate these signals and apply it to a number of very strange Kepler targets. We say, no, no, these aren't artificial, these are normal, natural things. But we couldn't 100% rule it out for the star that was discovered by the planet hunters. And that's literally all that the discovery says. And then, as sometimes happen in the media, the fact that one of the papers uses the phrase alien megastructures was then tied to this star and said, oh, there must be aliens around here. To be fair, we're not saying it's aliens, but we also cannot say that it is not aliens.
So I did a bit of writing on this a few years back, actually probably more like 10 years back, that different kinds of shapes of alien megastructures that, you know, as they transit in front of the planet, if they're triangular shaped or if they're square shaped, that would give a different signature, the kind of thing that actually could be seen. So this isn't a totally crazy idea to do a survey of stars and potential transit events, looking for signatures that would almost have to be artificial in nature, because you would see, you know, it would be spheres. If it's not a sphere, then there's something interesting going on there, and one plausible explanation. So, you know, you talked a bit about maybe a swarm of comets. Can you rule out other stuff that it for sure isn't? Like, it's not a planet?
So we can rule out it's not a planet, as any traditionally defined planet would be, because the signals don't occur at regular intervals, and they don't occur with the typical transit shape that a planet would have. Like you said, the great thing about transits is that when you look at the light curve that they produce when they do transit, it tells you a lot about the shape of the objects, which is why we could think about maybe distinguishing a megastructure from a planet. So we can rule out a planet. It doesn't look like one. We can rule out a very young star that maybe has some leftover star-forming or planet-forming material, because we don't see a lot of light coming out of the infrared where we would expect that material to be very luminous. So we can rule out a few natural things. Young stars, forming planets, a ring system, a few things. But there are still some natural explanations that could work. I know of at least one proposal to get more observations of this target in different wavelengths, so that we can try and figure out what the most likely explanation is. It's probably not aliens.
I might have missed it, Kimberly, but did they rule out star spots on the star itself?
Yes, I believe they did, because this is a type of star, it's an F star that doesn't have too many star spots on it naturally. So unless one of the other possible explanations is that we just haven't characterized the star well enough, and maybe it is, against all odds, something that would produce a signal like this.
Go ahead, Pamela.
What's really cool is, no matter what the solution is, we have either found a star that is undergoing thus far completely unique variability, whether it be sunspots or some other stellar astroseismology, something or other that's in a non-periodic way behaving, or we have encountered a very brief episode of solar system evolution, whether it be the comet model or the worlds colliding a model, in which case, again, really unique, very brief, visible, we got lucky that it was in the Kepler field kind of situation. Or we found our first alien civilization, again, highly rare, highly unique. So whatever it is, this is new science, and we're going to be busy for a while.
Yeah.
That is so true. We're going to learn something very interesting, no matter what it turns out to be.
Yeah.
I like the phrase "against all odds" because the universe is a really big place, folks. If this strange mechanism that Kimberly or Pamela is describing is a 1 in a billion possibility of happening, then we just happen to catch one of 100 places in the galaxy where it's going on. If there's one thing that I think exoplanets in the last 20 years has taught us, is that if you can imagine something just ridiculous happening, there's somewhere out there in the galaxy that exact situation is occurring. And I think this is just the most extreme version of that we've had a chance to see yet.
It's Larry Niven's ring world.
But even if it was some kind of alien megastructure, wouldn't that have a regular, if it was orbiting, would you expect that to have a fairly regular pattern of blocking the light and not?
So in that case, it wouldn't be so much a completed structure. We might think of it as something maybe in progress, something that is still changing.
Not a fully operational space station.
Not a fully operational space station quite yet. But if you
potentially partially destroyed. It could be either side.
Is this Star Wars product placement?
Wait a minute.
The
fix is in. We know what you're up to. You're going to be raising the promotion, and then it's going to be revealed.
It's perfect timing.
Yeah, that it's for the new Star Wars movie.
Yeah, so we might expect something that was still being assembled, for instance, where like different sized pieces of the future completed Dyson sphere or something like that could be being maneuvered into place, and so those shapes would be whatever size those construction pieces would be, and whenever they happen to be assembled.
Right. Or just an awful lot of comets.
Or it's the Death Star that's just destroyed Alderaan. Who knows?
Transitory phenomena involving the destruction of a world.
So not to be confused with Aldebaran.
So when will we get more information? What's the plan? You mentioned there's going to be some follow-up observations are planned. Are you going to be working on this?
It's not yet certain what I'm going to be working on the next few years. I certainly wouldn't mind taking another crack at this object. There is a proposal that was just put in not too long ago to observe this through the SETI Institute, through that Breakthrough Initiative, and we hope to hear more about that in the next few months, so keep an eye out.
That's awesome. Yeah, I don't think people realize your name is actually on this paper.
Yeah.
You're the second investigator on this paper that talks about this.
Yes, I am. I was actually interviewed by Business Insider yesterday, and a few people have picked up the story, so it's been a pretty crazy media week.
I hope your interaction, your involvement on the Weekly Space Hangout has properly prepared you for the media.
Well, it certainly wasn't a foreign concept anymore.
That's awesome. Okay, great. So before we wrap up, Dave, you've got sort of one quick thing in the sky that people should be looking for.
Yeah, we have all the classical planets in the morning sky right now except for Saturn. And Jupiter and Venus are getting closer and closer, and it's going to culminate with a close 1 degree, which is close enough to put in the field of view of a telescope, backyard telescope, a 1 degree conjunction on October 25th, next Sunday morning of next weekend. Venus and Jupiter are going to be 1 degree apart. And there's some discussion going around on the web. I wanted to write about this, and I did on Universe Today because a lot of people are calling this a Star of Bethlehem conjunction, and I notice every time I have a Venus-Jupiter conjunction, now it's becoming a Star of Bethlehem conjunction. This stems back to a close conjunction in 2 BC, where you had Jupiter and Venus near Regulus, and we also have that same sort of similar pairing, but I'd also like to point out Jupiter and Venus, they meet each other almost every year and every other year. It's not a once in a millennia, once a century kind of thing. It's kind of becoming the next Mars hoax kind of viral meme out there right now. So it's interesting to look at older. I actually ran a simulation of conjunctions over 18,000 years to look for close occultations. I had the question posed to me, does Venus ever actually occult Jupiter, like pass in front of it and actually block it out? And this is actually is rarer than those kind of Star of Bethlehem Regulus conjunctions, which happen about on average every 11 or 12 years. I didn't find one actually looking through 18,000 years of closer than 1 arc-minute conjunctions between Jupiter and Venus. I found some that were really, really close, where Venus was almost large enough in the right circumstances. I found there's actually one coming up in 2065 on November 22nd that we're going to see Venus pass transit in front of Jupiter, but it's going to be too tiny. I'll probably be in my second cyborg body by then. I might still be around, but it's interesting to note these kind of astronomical wackiness on like large timescales. It was an interesting exercise and thought experiment, and I put that all up there on Universe Today, a list of, for this millennium, all the close transits of Venus in front of Jupiter. It was kind of interesting. I learned some stuff.
That sounds terrific. Everybody should go to Universe Today right now and read that story.
Can I just complain that the morning sky is hogging all the planets, and I teach an evening night lab? Can we not have this happen? What's next semester going to look like? That's what I want to know.
Yeah, I'm at the gym every morning, and we have to go and run outside at like 6 in the morning, and
do the row work.
It's right there for me. This is for me, not for you, Nicole.
No, but my students will not get up at 6 a.m. for a lab. I won't get up at 6 a.m. for a lab.
The ROTC students. Clearly you need more ROTC students.
I have one, but he's got training at that time.
Right, and you should look up then.
That's true. That's true. But he can't. Yeah.
All right, so we should wrap this up. So I want to apologize to all of the people who posted some really wonderful questions. We just literally ran out of time, and there were some really great, very supportive comments from the people watching this, and want to let you know how much your words mean. And I know that everyone's been looking at the Q&A and seeing all the questions and all the comments and all the show of support. So thank you so much. I say that for everyone in this group, both with all of your comments on Carolyn Porco and as well as the sexual harassment stuff. That's really great. Thank you very much. Right, so we should wrap this up. So let's find out how people can find out more. Dave Dickinson.
Oh, yes, this week I was active on Universe Today, of course, Sky and Telescope Online, and my own site, Astro Guys with a Z, and if you go there, we have more free fiction goodness. I have another chapter of Standard of Deviation, which is available on Amazon as well, up for free to read on my site.
Kimberly, apart from your breaking news of discovering aliens, how can people find out more?
Well, you could always read more about my work discovering aliens. I have no problems with that. But if you don't want to read about aliens, you can follow me on Twitter at AstroKimCartier, or my website, KimberlyCartier.org, where you can find out more about the non-alien work that I do.
Morgan, where do we find out more?
We're also predictable now. You can follow me on Twitter at Morgan Rehnberg, or visit my website, surprise, surprise, morganrehnberg.com.
I do see a theme. Nicole.
And I'm going to break it. Yeah, hi, I am Nicole Gugliucci. I'm Noisy Astronomer. Yeah, I broke it. But my actual Twitter handle is Noisy Astronomer, and I got my website working again. I left it alone for far too many months, and it got hacked. But I fixed it, and I cleaned it, and I love you, DreamHost, for helping me. So yeah, noisyastronomer.com, links to stuff that I write occasionally there, on Skeptic, School of Doubt, other places. And I teach a lot. And I grade a lot.
And if a person wanted to take an astronomy physics course with you, where would they find you? You're not where you want to go.
I'm now in New Hampshire, so I am now a professor at St. Anselm College in New Hampshire, and I am teaching 2 astronomy courses next semester, so I'm pretty excited about that.
That's fantastic.
Yeah.
All right, Pamela, where do people find out more?
Professionally, I live at CosmoQuest where you're invited to help me map out our universe. And if you want to hear my personal ideas, thoughts, essays, you can find them at starstrider.com, and I tweet as @starstrider, again with a Y.
She's got a good one this
down
week.
in my 20s. Yeah, I have a really good essay up on my blog right now about the Jeff Marcy incident that we were talking about today.
Ooh, I'll link to it in the thing.
Great, and once again, I'm Fraser Cain. You can find me on Twitter @fcain. I still don't like it, Nicole.
Yeah, that's right. I did pick on you this week.
Yeah, but you can find me there. And also, we've been posting a bunch of really great videos on YouTube. So if you want to learn about the universe expanding faster than the speed of light, about how red giants expand. We've got something coming out about the black hole information paradox. Subscribe to this YouTube channel. You're watching it right now. You're enjoying it right now, but go ahead and subscribe. And once again, a big thank you to the Weekly Space Hangout crew, especially, again, Nancy Graziano for organizing this interview with Dr. Carolyn Porco.
Congrats, Matt.
I'm speaking of things that I can check off the list, getting a chance to hang out and talk with Dr. Porco is just terrific. So, but the guests, the panelists, a lot of this, the stories that we choose, this is all coming from the WSH crew. So if you want to be a part of this, of helping the show get made, join that community on Google+. All right, well, thank you everyone for joining us. Sorry we went a little long, but it's kind of worth it. Thanks to the panelists for joining us this week, and we will see all of you next week.